in this object how to draw its side view, its missing top view. So for that, let me assume its isometric view. What would be its isometric view? You can see here with the imagination, the isometric view of this object would appear like this. This is the isometric view of the object, and this is the given data, and this is the isometric view of the object. You can see here. So first of all, you roughly draw the isometric view of the object, not needed to be drawn to the scale. Then after, draw its front view like this. You can draw this front view. It's not difficult to draw this view. Now to draw its top view, let me pick up from this end. If we start from here, these two lines, parallel lines, would start from here and end to the another side. So draw that line like this. From this end to this end, two full lines would appear like this, and this rectangle represents this upper portion, this one, right? And circular hole is there. So for that, we need to insert the center line of this object. The center line of this object is somewhere here, like this, at the middle. So this is the center line. Now about this rib and this cylinder, we know about this cylinder, horizontal cylinder, having diameter is known to us, height is known to us. So according to that given dimension, diameter of the cylinder, that is 60 millimeter given, and height from a base to end, that is 50 millimeter. So it would appear like this. This represents this cylinder, this one, outside line of this cylinder. Now think about this upper portion, this one, this is strip, and this one. We know this distance from center line, this center to this, that is equal to the radius, and the radius is given in the figure, that is 15 millimeter. So 15 millimeter on either side, a full lines would be there, and this height is known to us from this end to this end is known to us, that is given as 22 millimeter, and here full line. So this box represents this top view. Now about this strip. Strip is having thickness in the figure 10 millimeter. So it would appear as a full line like this, from this end to this end. This represents this slant strip. Now about this portion, this circular holes, which is at a distance known to us. So for that, draw a center line like this on either sides, both the sides, and the distance is known to us, that is diameter of the circular hole is given as 16 millimeter. So 8 millimeter on either side, draw dotted lines like this, and 8 millimeter on this side like this. Similarly 8 millimeter on this side and 8 millimeter on this side. So this represents the position of the circular hole which is there inside this strip. Now about this inner hole, here a circular hole is there which starts from this end and ends to the another end. So that is to be represented by dotted line in the top view. So here dotted line will start from the top line to the end line like this. So here also dotted line would be there, and this dotted line represents the inner circular hole in the cylinder like this. So this is the top view. Now about this circular hole, this one, in isometric view you can see here this circular hole. The diameter of this circular hole is given as M14, that means 14 mm is the diameter. So 7 millimeter on either sides. Here, from here we can take the projections and draw dotted lines to show the edges of the circular hole. So this is another view, and this is the missing top view of given figure. This is front view of the figure. In examination, only missing top view is needed to be drawn. So you can directly draw this top view. You need not to draw this front view. Just here it is drawn for the reference. To understand the concept, it is drawn over here. And this slant edge would not appear in the top view because it is hidden behind this corner and behind this corner. So I hope the solution of this problem is clear to you. That is missing view of an object. Now next problem. Problem number 5a, asked for 7 marks. An assembly of drawing of socket and spigot joint is shown in figure 5. Draw detailed drawings of each part in 2 views using first angle projection method and prepare a part list. So here socket and spigot joint is shown in the figure like this. This is the diagram of socket and spigot joint having a cotter inserted inside. So this figure is given in the examination, and it would, here you have to disassemble these 3 components, and after disassembling these 3 components you have to draw 2 views of each component. So before that, let me visualize what is the actual assembly, how to assemble this cotter, socket and spigot joint. It is shown over here. This is the assembly of socket and spigot joint. This is a cotter which is inserted inside this socket end, and this is spigot end, and here a removed material is there for the easy insertion of this cotter. The cotter is made slightly taper so that it will not be thoroughly entered. Now next clip, for the same kind of cotter joint, you can see here this is a cotter joint. Now we had drawn the solution of this paper in the earlier discussions. Right now I will show you just the solution of that problem. It is to be drawn like this. You can see here 3 views are to be drawn like this. Here socket end is there. This is the socket end. This is front view of the socket. This is side view, spigot end, side view and front view, cotter, front view and top view. You can easily draw because the dimensions are given in the assembly. And here in the detailed drawing, you can see here these dotted lines are represented. These dotted lines represent the inner portion because sectional view is not drawn here. In side view, circles would be there. In spigot end, this would be the spigot end, and this is the cotter of given assembly. The cotter is drawn slightly taper over here. So because of the taperness of this edge, here you have to draw 2 lines, this full line and a small dotted line over here. This small dotted line represent this edge, and this distance, the distance between this full line and dotted line, shows the taperness of this cotter. Now next, question number 5b, asked for 5 marks. Draw surface roughness symbol for following details. Roughness value 6.3 microns, production method, that is grinding, sampling length 60 mm, machining allowance 2 mm, type of lay circular. The question is asked for 5 marks and 5 elements you have to represent in the surface roughness symbol. So for that, first of all, draw the symbol of surface roughness like this. This is the symbol of surface roughness, and we have to represent these values. So first of all, draw the triangle like this. This yellow colored portion represent the surface which is to be machined. Now first, that is roughness value 6.3 microns, which is written like this. Just write 6.3 over here. No need to write micron or micromillimeter, just write 6.3. Now second is process of surface preparation, that is grinding. So just only write grind over here, above this line. Above this triangle over, write surface roughness value in terms of micron. Here just write grind, G-R-I-N-D. If the preparation of surface is milling operation, then write M-I-L-L, mill only. If it is turning, write turn only. Now third one is sampling length, that is 60 millimeter. So that is to be written like this. Before this grind, write 60 in terms of, and this parameter is to be inserted in terms of millimeter. So no need to write mm over here. Then fourth one is machining allowances, that is 2 millimeter, which is to be written over here. Only 2, just 2 on this side from this triangle. And type of lay, that is circular in this case. So write C over here, which means that the type of lay is circular. So if this symbol is drawn on any drawing, nothing is written, it means that the roughness value of this surface is 6.3 microns, and this surface is to be prepared with the grinding operation, and length of sampling should be taken as 60 millimeter, and allowances for machining operation is 2 millimeter. We can reduce or we can remove the material up to 2 millimeter thickness only, and the lay of the pattern should be circular. Next question. A cone diameter 75 millimeter, height 90 millimeter is resting on HP on its circular base. A cylinder of diameter 50 millimeter, height 100 millimeter is resting on HP on its circular base. The plane passes through both the axes, makes an angle of 45 degree with vertical plane. Distance between both the axes is 10 millimeter. Draw curves of intersection. So here cone is given, diameter and height are known to us. It is resting on HP on its circular base. And another cylinder which is there, having axis 100 millimeter and diameter 50 millimeter, resting on its circular base, and the distance between axis of both the solid is given to us, that is 10 millimeter, and the plane which passes through both the axes makes an angle of 45 degree with vertical plane. So the solution of this problem is to be drawn like this. This is the solution of this problem. You can see here. First, to draw the solution of this problem, first we draw a circle. This circle which represents a diameter of cone and triangle height. So first of all, draw a triangle and circle to represent this cone, and after that, from the center line, this axis, draw a line at an angle of 45 degree, and from that pick up the axis of this cylinder, which is at a distance of 10 millimeter from the axis of this cone. So from here, this axis at a distance of 10 millimeter on either side, draw axis of another solid. So this distance, this one, is 10 millimeter because it is given in the data that the distance between the axis is 10 millimeter, like this. And draw the center line. After drawing the center line, draw here a circle equal to the diameter of the circle, that is equal to 50 millimeter. So draw this circle. After drawing this circle, divide this cone into equal number of parts, say 8 equal parts, O1, O2, O3, O4, 5, 6, 7 and 8. Then after, draw front view of this cylinder like this. That would be rectangle. Height is known to us. So we have drawn front view and top view of both the solids. After that, to find out the points of intersection of both the solids, let me pick up points on this periphery of this cylinder. suppose here is the point P1 which is on generator O1. O1 is the imaginary generator drawn over the cone, and O dash 1 dash is the generator front view. Now on O1, this cylinder cuts O1 at this point, that is point P1. So from this point draw straight vertical line that will cut the generator O dash 1 dash at one point. This is P1 dash point, that is position of point P1 in front view. Now to pick up the point number 2, say on O2, generator O2 is there, point number P2 is there on O2 somewhere here. So from here draw straight vertical line like this, and that will cut generator O dash 2 dash. Here 2 is there, so from here draw vertical line, here is point 2 dash, and O dash 2 dash is the generator. So from here on O dash 2 dash, point number P2 dash is there, so mark here point number P2 dash. Similarly P3, P4, P5, P6 and so on. About P3, take O as a center, O to P3 as a radius, draw an arc like this, draw vertical line that will cut O dash 1 dash over here. From that draw horizontal line that will cut O dash 3 dash at this point, that is point P3 dash. With a similar analogy, we can pick up all the points 1, 2, 3, 4, 5, 6, 7, 8 and back to 1. So after locating all these points, if we look from this side, from here, this P1 to P5 point would be visible. So join all these points with the full line and rest all points with the dotted line or dotted curve. This edge O dash to P1 and O dash to P5 would not be visible, hence to be represented by dotted line, and these edges of the cylinder that will also not be visible, hence it is represented by dotted line like this. So red color is the cylinder and black colored portion is the cone. So I hope the solution of this problem is clear to you. I am very much thankful to all of you for being with me, and I wishing you all the best for your GTU examination in this subject. Thank you. Thanks to all.